Hi, welcome to my video on the addition and subtraction of fractions with different denominators. The previous video was on the same denominators. So let's see how we can add and subtract with different denominators. Another method to do equivalent fractions is going to be discussed down below. But first of all, let's look at 1 equals c over c, where c belongs to the natural numbers. Example, 1 could be 2 over 2, 3 over 3, 4 over 4, depending on what you want your denominator to be. And a over b times 1 is a over b. That's the identity element of multiplication. So a half times 1 is a half. 2/3 times 1 is 2/3. 4 over 7 times 1 is 4 over 7, etc. Let's find the equivalent fraction by either of two methods. The two methods we're going to look at is that, notice I have a over b, but I'm multiplying top and bottom by c to get ac over bc. Or I can take the fraction a over b that I have here or here and multiply it by c over c. It still gives me ac over bc. So either put one each on the top or multiply the fraction by c over c, which is what I'm doing up here. Let's try some. 6 over 7 when c is 2. So 6, 7 multiplied by 2 over 2. Or, we keep going, this 3 over 4 multiplied by 5 over 5. 2/9 multiplied by 3, 2 over 9 multiplied by 3 over 3. The reason I did all these together is to be consistent and not jump back and forth. When I do that, let's go back to the first one. 6 times 2 is 12. 7 times 2 is 14. 3 times 5 is 15. 4 times 5 is 20. 2 times 3 is 6. And 9 times 3 is 27. If I look at the other method, then I'll take the 6 over 7, 6 and 7, and I multiply it by 2 over 2. 2 over 2 is 1. So 1 times 6 over 7 gives me 6 over 7. But right now we want equivalent fractions. So 6 times 2 is 12, 7 times 2 is 14. Notice the answer to both methods is the same. It just depends on how you wish to write it down. 3 over 4 times 5 over 5, which is 15 over 20 when you multiply. 2/9 times 3 over 3, multiplying it by 3, gives me 6 over 27. Same answers, but so it's up to you when you go to multiply to get equivalent fractions. Let's practice. 1 over 10 multiplied by 7. 1 over 10 multiplied by 7 over 7. 6 over 11 multiplied by 4 and 4. 7 over 12 multiplied by 10 and 10. That gives me 7. That's a 10, sorry. And that's a 70. 6 fours are 24. 11 fours is 44. 7 times 10 is 70. 12 times 10 is 120. And the other method, we take the 1 over 10 and we multiply by 7 over 7, which is 7 over 70. And we take the 6 over the 11, multiply it by 4 over 4, which is 24 over 44. And we take the 7 over the 12 and multiply it by 10 over 10. And that gives me 70 over 120. So notice the two methods are the same. It just depends if you want to multiply it by 2 over 2 or multiply numerator and denominator by the 2. You're still doing the same thing. Your choice. Let's add and subtract fractions with different denominators. Let's add 1/4 and 1/2. The rectangles I have here are identical. So if we take A and make it 1/4, 1/4 would be 1 out of 4. So that means I have to divide A into 4 pieces, and I have to take one of them. So that's 1 out of 4, 1/4. B, if I let B be at the half, a half means 1 out of 2. So I take the half and shade in 1 out of 2. So notice 1 out of 4 and a half. But notice that a half and 1/4 are different denominators. So if I take the half and, which is right here, and divide it into 4 pieces, this half, this right here, still there. But notice now, the 1/2, which is 1 out of 2, now becomes the 2 out of 4. So now I have 1 out of 4, 2 out of 4, the same denominators. So when I add these up, 1/4 plus 2/4, I get same denominators 4. So I add the numerators of 1 and 2, and that gives me 3/4. So notice we're still adding, but I have to have the same denominators when I add. So you have to write each fraction with the same denominator. So if I look at it from another point of view, 1/4 plus 1/2, in math, if I multiply the 1/2 by 2/2, 1/4 plus 2 times 1 is 2, 2 times 2 is 4. And that brings us right to there. So I have to make equivalent fractions with the same denominators. So why I just multiplied by 2/2, 3/3, 4/4 was to make equivalent fractions. To add or subtract fractions with different denominators, follow the steps. I memorized these steps. Find the LCD of the fractions. Remember, the LCD is the LCM. Don't forget, when you're finding the LCD, you're really finding the LCM of the numbers. Express each fraction with the LCD, which that you're making a pair of equivalent fractions. Because when you make them equivalent with the same LCD, then we're able to add the numerators or subtract the numerators. We add or subtract the numerators and we keep the denominator. That's what we practiced in the previous video. And then we simplify or reduce, if possible. Always reduce or simplify. So let's try some. 1/3 and 1/6. Well, we can see that the least common multiple, the LCD of 3 and 6 is 6. So 6 is okay here, but we need to multiply 1/3 by 2/2. So that makes it 2 times 1 is 2, 2 times 3 is 6, and lo and behold, we have the same denominator. So we keep the denominator and add our numerators. So I'm just adding these very quickly. 3/6, we reduce it. 3 into 3 goes once, 3 into 6 goes twice. So notice we're adding different denominators. So we have to make equivalent fractions with the same denominator. Number 2, 3/8 and 1/10. So we look for an 8 and a 10. We need an LCM or an LCD. 8 is 2 times 4, which is 2 times 2. So that's 2 cubed. 10 is 2 times 5. So the LCM or the LCD is we have to have a 2 and a 5. We take the exponent of 3 because that's the highest for the 2. Exponent of 2. 3 is the exponent here. 1 is the exponent here, so we take the 3, the larger one. So 8 times 5, we get an LCD of 40. So we go back and make equivalent fractions now. So 8 is to get 40. 8 into 40 goes 5. So we put 5 on the bottom, 5 on the top. And when we do 10, 10 into 40 goes 4. So 4 times 10 is 40. So we put 4 on the top. Because 4/4 is 1. So we're making equivalent fractions. 5/8 are 40. 10 times 4 is 40. Notice same denominators. So 5 times 3 is 15. 1 times 4 is 4. And we add 15 plus 4 is 19 over 40. Notice 19 can't be reduced. It's a prime number actually, so we can't reduce it, so we leave it as 19 over 40. Let's go with 6 and 21. Is 6 and 21. If you can pick up the LCD right away, we'll go for it. But if you can't, you got 6 is 2 times 3. 7 is 21 is 3 times 7. So I have a 2 times 3, 3 times 7. So the LCM or LCD is a 2, a 3, and a 7. And the highest power is a 1. So that's 6 times 7, 42. Go back to the problem. What number do we multiply 6 by to give me 42? It's a 7. So we make it 7 over 7. What do we multiply 21 by to get 42? 2. 21 divided into 42 is 2. 2 on top and bottom. Multiply. 5 sevens are 35 over 7 sixes 42. Subtract. 17 times 2 is 34 over 21 times 2 is 42. Notice we have the same denominators, 42. So 35 subtract 34 is 1. Can't reduce it. Notice I'm keeping everything together here. You can do more steps, space it out more. So I'm trying to save time and save space because it's a video. I don't want to use up a lot of time. And we have 15 and we have 10. 15 is 3 times 5. 10 is 2 times 5. So you notice we have a 2 and a 3 and a 5. I could go 3 times 5 and 2 times 5, but if you practice this often enough, you can see that we just go 2, 3, and 5 looking at these. And that's 6 times 5, 30. So the LCM, which is the LCD of these fractions, is 30. So we multiply 15 by 2. 15 times 2 is 30. 2 on top. We multiply 10 divided into 30 is 3. 10 times 3 is 30, so we need a 3 on the top to make equivalent fractions. 2 times 15, 30. 2 times 13, 26. Subtract. 10 times 3 is 30. 7 times 3 is 21. So notice we have the same denominators of 30. Good. 26 subtract 21 is 5. Notice 5 is a factor of both of these numbers, so we divide each number by 5. 5 into 5 goes once. 5 into 30 goes 6. Again, not hard to do. Just follow the patterns, follow your steps, and memorize. Write them down. Learn them. You'll never go wrong. If you keep practicing my videos from the beginning video over to the end, you'll see that everything falls in place. More. Let's see, 15. Sorry. 12 and 8. I don't know where I got 15. I must have seen the 5 there. 12 is 3 times 4, which is 2 times 2. So that's 2 squared times 3. That's the prime factorization. 8 is 2 times 4, which is 2 times 2. 8 is 2 cubed. So we look for the LCD or LCM, same thing. LCD, LCM on these numbers, we have a 2 and we have a 3. And a 2, we pick the highest exponent, 3. Square and a 3, we pick the 3. 3 is only one of them. 8 times 3 is 24. So we go back and we say, what number? 12 and 24 goes 2. We need a 2. 8 and 24 goes 3. So we need a 3. Notice, 2 times 12 is 24. 8 times 3 is 24. So we put a 3 here, 3 on top. Keeps it equivalent. 1 times, notice 2 over 2 is 1. So we get a, add here, we get, when we multiply, we get a 10 on top, 24 on the bottom. 3 times 3 is 9, and 8 times 3 is 24. Notice the two denominators are the same, so we write down our denominator and add up our numerator. 19. 19 cannot reduce, so there's the addition simplified. Number 6, we have a 20 and a 50, being two fractions subtracted. Let's see, 20 and 50. If you could look at 20 and 50 and say 100 right away, because a multiple of 50 is 100, and 20 goes into 100 5 times, then you could do 100 right from the start. But if you can't, then 20 is 2 times 10. 10 is 2 times 5. So that's 2 squared times 5. 50 is 5 times 10, and 10 is 2 times 5. So that's 2 times 5, and there's 2 5s. If you look at it, I have a 2 and a 5 in each. And 2 has a 1 and a 2, so I take the highest. 5, that's a 1 and that's a 2, I take the highest. 4 times 25, again I said, if you could have recognized that this was 100 LCD right away, then you could have done it and moved on. 20 into 100 goes 5, put a 5 on top. 50 into 100 goes 2, put a 2 on top. Notice 5 times 20 is 100. 5 times 13 is 65. 50 times 2 is 100. 31 times 2 is 62. When we subtract, we bring down the 100 because we're subtracting fractions. 65 subtract 62 is a 3. Can't reduce it. 3 is prime. 9 and 27. If you could see that 27 is a multiple there, least common multiple, then you go for it. You only got to multiply that by 3. But if you don't, 9 and 27. 9 is 3 times 3, which is 3 squared. 27 is 3 times 9, which is 3 times 3. So that's 3 cubed. We have a factor of 3, and the highest exponent is 3. So that gives me the 27. Notice the multiple of 27 takes care of the 9, because 9 is in 27. So if we multiply the 9 by 3, 3 on top, 3 9s are 27. 3 times 1 is 3. We do not have to touch this one because it's already a 27. You can multiply by 1 over 1, but that's really not going to do much for you. It's the same thing. And when we add, write down the common denominator of 27 and add. 3 and 2 is 5. 5 is prime. 27 doesn't have a vector prime, so it's done. Number 8 is a little tiny bit different. We work out, remember the order of operations? And we had PEMDAS, PEMDAS, or we had BEDMAS, your choice. BEDMAS, same thing. I use this one all the time, but a lot of teachers and books use PEMDAS. But we got to do the inside. So let's do the inside of this bracket. Common denominator for 3 and 5, multiple is 15. So that means I got to multiply this fraction by 3 over 3. Multiply this fraction by 5 over 5. That gives me 12 over 15 and 5 over 15. And if we work out this one too, common denominator for 10 and 15, if you can see that as a 30, perfect. If you can't, you got to work it out. 10 is 2 and 5. 15 is 3 and 5. So we got a 2 times a 3 times a 5. We got a 2, a 3, and a 5. 1, 5. Yep. They're all 1s, so that's a 6 times 5 is 30. So 30 times what number? 3. 15 times what number? 2. 21 over 30. 14 over 30. So let's work out. So notice we have inside of these, we have different denominators. So we have to do LCD for the inside of here, and the inside of this one are different. But 15, 12, subtract 5 is 7. 30, we have to do the inside. 21 subtract 14 is 7. Now we have to get an LCD for these two. And the LCD, if you notice, is 30. Because 15 is a factor of 30. So if you make it a 30 and you see it right away, then you can go 2 and 2. Because 15 times 2 gives me 30. So I have to put a 2 on top and bottom and get 14 and 30. We don't have to touch the one on the right because it's already the LCD. 30 is my denominator, write it down. 14 subtract 7 is 7. So notice I worked out the two brackets first and then I subtracted these after by getting the LCD. You could get the LCD for the whole works up here, but it's better to do each bracket separately and then subtract after. Number 9, 1 subtract 3/5. 1 is the same as 5 over 5. Why 5 over 5? Because my denominator is a 5. So 5 over 5 is 1. Since I have this equivalent fractions with the same denominator, I have a 5. 5 subtract 3 is 2. So notice 1 is 5 over 5. And we have more. Always good to practice. Practice means you can work these out first and then hit the play button and see if you're right. And if you're right, perfect. If you're not, see where your mistakes are. Let's go. Common denominator for 10 and 5 is 10. We can see you don't have to do too much work. So we make that a 2 and we do that a 2. Why? Because the 7 over 10 is there. And 5 times 2 is 10. So 2 times 1 is 2. We multiply 5 by 2 to get the common denominator of 10. So the top has to be multiplied by 2 also. That's 10 is the common denominator. 7 subtract 2 is 5. Notice 5 is in both numbers. We divide by 5, and that gives us 1 and 2. 5 divided into 5 is 1. 5 divided into 10. Remember, we could do this. Divide by 2 on the top, divide by 2 on the bottom, and that gives us, divide by 5. My mistake. 5 divided by 5 is 1. 10 divided by 5 is 2. But it's just as quick to divide in your head. Save your time. Notice the common denominator for 9 and 3. Multiple is 9. So that means you got to multiply the fraction on the right by 3. 3 times 3 makes 9. So you got to put a 3 on the top to make it equivalent. So 2 over 9 for the first one. And this one is 2 times 3 is 6. And 3 times 3 is 9. Common denominator is 9. Write it down. And 2 plus 6 is 8. Can't reduce. 8 is even number. 9 is, the only factors of 9 are 3 and 3, so we can't reduce. Now we got a 7 and a 2. Common denominator for 7 and 2. Multiple of 7 and 2. If you see that the LCD is 14, because what? These are prime. You have to multiply them. So that means the first number is multiplied by 2 over 2 to get the 14. The second one, a half, is multiplied by 7 over 7 to get the 14. So 2 times 7 is 14. 2 times 3 is 6. 2 times 7 is 14. And 1 times 7 is 7. And when you add these, you keep your denominator and add your numerators. 13. 6 and 7 is 13. Notice when I work these, I put one number on the right and I put the other number on the left. That keeps my two denominators, 2 and 7, 2 and 7. Not that it makes any difference. You could put the 7s in here if you want. I just put them out here. Gives me space. Common denominator for 11 and 3. We're subtracting. We need a common denominator. And the common denominator is their product. Because these are prime, no common factors, we can say 33. So the LCD is 33. That means we got to multiply the first fraction by 3 over 3. Multiply the second fraction by, notice I got dots here. I have a habit. I can do multiplication if you want, just to be consistent. Sometimes I put dots, sometimes I put multiplication. Just beware, I mean a multiplication there. And that's 11 over 11. 11 times 3 is 33. So multiply this one right here. 3 times 10 is 30. 3 times 11 is 33. 1 times 11 is 11. 3 times 11 is 33. Same denominator, 33, write it down. And 30 subtract 11 is 19. 19 is prime. There's no factors. 19, the only factors are 1 and 19. Prime, can't reduce. 6 and 4, again, easy numbers. If the numbers are easy, if you can see a 12 here, but if you can't, just go 6 is 2 times 3. 4 is 2 times 2. So that's 2 times 3. That's 2 squared, 2 times 2. That's a 2 and a 3. We got 2 has a 1 and a 2, so we picked 2. And 3 is 1, so that's 4 times 3 is 12. 12 is the LCD. When you do fractions so long, after a while you get used to the multiples or common denominator. So that means the first one, common denominator is 12, so I need a 2 on top. I need a denominator 12, so I need a 3. And because 4 into 12 goes 3, 3 and 3. Whatever number you put on the bottom, you put on the top to make it equivalent. So that's a 2 6s are 12, 2 5s are 10. 4 times 3 is 12. 3 3s times 3 is 9. Common denominator is 12. Write it down. 10 subtract 9 is 1. Can't reduce. Done. 14 and 21. If you can't see the LCD, break them down. Prime factorization. So 14 is 2 and 7. 21 is 3 and 7. Notice no numbers in common. 2, 3, and 7. 6 7s, 42. Notice when you work these out, show you a little trick. 14 is a 2 and a 7. So the 3 is left over. 21 is a 3 and a 7. The 2 is left over. So if you have it done like this, you can see what the other number is going to be. 3 times 14 is 42. 3 times 11 is 33. 21 times 2 is 42. 13 times 2 is 26. Common denominator is 42. Write it down. 33 subtract 26 gives you a 7. 7. And is 7 a factor of 42? Yes. 6. 6 times 7 is 42. So 7 divided into 7 is 1. 7 divided into 42 is 6. So you have to check to see if the 7 is a factor. 42 divided by 7 is 6. So reduce. 18 and 27. Now notice I kept making them a little bit harder as I go. 18 and 27, I'm going to add on each common denominator. So 18 is 2 times 9, and 9 is 3 times 3. So that's 2 times 3 cubed. 27 is 3 times 9, which is 3 times 3. So that's 1, 2, 3. 3 cubed is 27. I have a 2 and a 3. 2 is okay, I got one of them. 3, I got 2 and a 3. So I need the cube, the largest one. 27 times 2 is 54. So we go back. What number times 18 gives you 54? And if you said 3, you're right. So you put 3 on top and bottom. 27 divided into 54 is 2. So you put 2 on top. 3 times 18 is 54. 3 times 7 is 21. 27 times 2 is 54. 12 times 2 is 24. So if you do multiply the bottoms first, you'll see the common denominators. So 54 is my common denominator. Write it down. 21 plus 24 is 45. Now look around. Can you reduce these? Well, let's see. 45 got a 5 and a 9. Oh, the digits adds up to be a 9, a multiple of 9. The bottom number, 54, same digits, adds up to be a 9. So both of these numbers are divisible by 9. So 9 divided into 45, 5. 5 9s are 45. 9 divided into 54 is 6. Check with your calculators. 5 9s are 45, 6 9s 54. Reduce down. Common denominator for 15 and 20. Well, if you can't see it right away, break it down. Prime factorization. 20 is 2 times 10, which is 2 times 5. So that's 3 times 5, and that's 2 squared times 5. There's 2 2's. I have a 2, I have a 3, and I have a 5. There's only one 3. There's a 2 squared, got to go. The 5 is a 1 and a 1, so it's just a 1. 4 times 15, and that's a 60. You could, multiply that whatever way you wish, but I just did a 4 and a 15 to get to 60. A 60 means I need a 3. So 3 on the top. 15 and the 60 goes 4, so I need a 4 on the bottom, 4 on the top. 4 times 15 is 60. 4 times 11 is 44. 20 times 3 is 60. 3 times 3 is 9. And common denominator is 60, and I subtract. 43 subtract, that's a 35. Check it out. Yep. 5 is a factor of each, so 5 into 35 goes 7. 5 into 60 goes 12. 7 is prime, so it can't go down any further. Number 8, we got brackets. Bedmass says what? PEMDAS says we do the inside of our brackets first. Common denominator for 6 and 3 is 6, so we multiply the left one by 2, 2 over 2. 6 is my common denominator, no change. 2 times 1 is 2. 3 times 2 is 6. Again, I'm working the inside totally. So 6 is my common denominator. 1 plus 2 is 3. But if you notice, if you wish, 3 over 6 becomes easy with a 1 over 2 because 3 goes into both of them. Now I have an easier denominator because what? 8 is the LCD of 2 and 8. So that means I can multiply by 4 over 4 because 4 times 2 is 8, 4 on top and bottom. So 7 over 8 becomes 4 over 8. 1 times 4 is 4, 2 times 4 is 8, LCD is 8, so 7 subtract 4 is 3. 3 is prime, can't reduce it. And we got number 10, we got a 12, a 6, and a 4. If you can see that 12 is an LCD of 6 and 4, you got it. But if you don't, you can work it all the way out. But if you think you might be able to see it, so we multiply 2 times 6 to give me 12. So we multiply top by 2. Multiply the 4 by 3 to give me a 12. So we multiply the top by 3. So 7 over 12. Head on. 2 times 1 is 2 over 12. Subtract. 1 times 3 is 3 over 12, because 4 times 3 is 12. All of them have the same denominator, so we write down the denominator. So we can add from left to right. 7 plus 2 is 9. 9 subtract 3 is 6. You can write them down and make another line if you want. Your choice. 6 is a common denominator. 6 into 6 goes once. 6 into 12 goes 2. 6 is a half of 12. Notice, everybody, adding fractions with different denominators. And notice the rules. Read them over. Memorize them. If you like my video, click the like button, the subscribe button, and the notification bell. And if you want, write a comment about how I'm teaching. And visit my website, www.mathfullyexplained.com. You find information about me, my degrees and teaching experience, and you find teaching strategies that I use to help students learn. And on the content section, you have the topics, the number of videos on each topic. You have the topic that's completed will be in black font, and the topics to be completed will be in red font. Hope you enjoyed the video. Bye-bye.